Okay, we're going to look at how we can draw a sign diagram for the following functions, which might be a bit more complex than the normal sign diagram. So let's start with A here, okay? And the first thing we need to know about these functions are these are what we call radical functions, okay? Because it's a function divided by another function, okay? So the most important thing that's going to be the case for both of these is that the function does not exist, dne, when the denominator is equal to 0, okay? And all that is saying is it's impossible to divide by 0. Okay, you can try it in your calculator. It's undefined. It's another word we often use. Undefined. It doesn't make sense mathematically. Okay, you can't have a cake and divide it by 0 people. It doesn't make sense. So what we're saying straight away then is that both of these functions are going to be undefined when their denominator is equal to 0. Okay, so for a sign diagram, we just draw an arrow across like this, and we're trying to illustrate where the roots of this equation are and where any possible asymptotes might be. Okay. Now, when the function is undefined, there is an asymptote at this point. Okay. So for function a, it's undefined when x is equal to. Okay. So what are we going to put in here to make that equal to 0? Well, 1 take 1 is just 0. So when x is equal to 1, the function is undefined. Okay, so this means we put here a 1 and we illustrate that with an asymptote like that. Okay, so we have an asymptote at x is equal to 1. The function is undefined. For any value of y or fx, the function does not have a value at x equals 1. Okay. The second thing we say is, what do we put into here that makes the function equal to 0? Okay, and for this part, you're mainly dealing with the numerator, the top. Okay, so what do we put in there that is going to make this function equal to 0? Okay, and the answer is minus 2. Minus 2 plus 2 is equal to 0, and 0 can be divided. Okay, you can divide 0 by 5, it's just equal to 0. Okay, everyone gets. If you have 0 cakes and you divide it by 5 people, everyone gets 0 pieces, okay? But you can't divide 5 cakes by 0 people. It does not make sense, okay? So when x is equal to 2, is equal to minus 2, we have 0 divided by minus 3, okay? And that's just going to be 0. So when x equals minus 2, the function is equal to 0. So we'll put that one in there, minus 2, and that's how we illustrate a 0, just a dot there. Okay, so here we have an asymptote at x equals 1, and we have one of the roots. The equation crosses the line at x equals minus 2. So then we say, all right, we need to find out if the function is positive between here, positive or negative between here, positive or negative over here, and positive or negative over here. The way we do that is we just choose a number either between. So for this region, between minus 2 and 1, we're going to choose a number between these 2 points, okay? 0 is a nice, easy number to deal with, okay? So let's say when x is 0, all right, we get y equals 0 plus 2, so we get 2 on 0 take 1, 2 on minus 1, which is equal to minus 2. This is negative, okay? So between minus 2 and 1, the sign function is below 0, okay, or it has a negative value. It's below the x-axis. Okay, what about when going over this side? Okay, a number that's greater than 1, but pretty easy to deal with. Let's use 2. So when x equals 2, we have 2y is equal to 2 plus 2, which is 4, on 2 take 1. 2 take 1 is just 1. This is equal to 3. 3 is positive. Okay, so to the right of the asymptote, the function is above the x-axis. Okay, and then to the left of minus 2, so let's say when x equals minus 3, we have y is equal to minus 3 plus 2, which is just minus 1, divided by minus 3 take 1, which is minus 4. Now minus 1 take minus 1 divided by minus 4 is positive 1 on 4, positive a quarter. So it's a positive number. So again, to the left of minus 2, it is positive. Okay. Now, we didn't need to work it out for this value here, okay? Just because we know that it's a linear equation, okay, and that it's not a square root, so it's not touching that axis, okay? So at this point, and then changing to there, these signs are going to be opposite one another, okay? But we have just proved that to the left of minus 2, it's positive. Mathematically, we've proved that by inserting a number. Okay, so that's how we solve this problem. I'm going to show you how we do the more complex one here now. Okay, so I might keep that information that we have there actually. Let me just get rid of this. Okay, so we've got the function x plus 2 on x take 1. So the first thing is the function is undefined. So we're talking about I now. I is undefined when x is equal to now. What we're talking about is the denominator. So the denominator is going to equal 0 when x equals 3. 3 take 3 is 0. Okay, x equals 3. So this means if we have the sign diagram, okay, that when x is 3, we have an asymptote. All right. Then we say, what do we put into the equation that's going to make it equal to 0? So again, we're looking at the numerator. And when x is minus 2, that factor is going to be 0, which means the whole thing is going to be 0. Okay, 0 times by that factor, no matter what it is going to be 0. So when x is minus 2, we have a 0. All right, so I'll put that one there. And then we have when x is 1, that factor is going to be 0. 1 take 1 is 0. Okay, so we have a 1 there. It's going to be another 0. So again, we're just going to need to put some numbers in between these to work out whether it's going to be positive or negative. Okay, so let's start between minus 2 and 1, and again let's use 0. Okay, so when x is 0, we have 2 times minus 1 divided by 3. Okay, this is minus 2 on 3, which is negative. Okay, so we've got negative here. All right, now you can do the same by choosing a number between 1 and 3. Okay, for example, 2, if you put 2 into there, okay, this is going to be a positive number. All right, I'm not going to go through this tedious process. And less than minus 2 as well, you could put minus 3 in there, and it's also going to result with a positive number. Okay, what we're interested in now then is beyond the asymptote. So let's say when x is equal to 4. All right, so if we put 4 in, we get 4 plus 2 is 6. 6 times 4 take 1 is 3. And that's divided by 3 take 4, which is minus 1. So you get minus 18. Okay, minus 18 is negative, so it's going to be negative there. Okay, so that's how we produce a sign diagram for these more complex equations. The only thing you need to be aware of is that it doesn't exist when the denominator is equal to 0. Okay, which means it has an asymptote at x being equal to this point. All right. Whereas the numerator is what makes the function equal to 0 when we have the root of the equation.